Assalamu alaikum. I am Dr. Shafiqur Rahman and giving a talk on the topic of cyber physical systems. Actually, we live in the century of industrialization where humans rely on technology. Without technology, we cannot compete the world and we cannot survive in the market. The technology that I'm talking today is cyber physical systems. To live up to date, it is very important to know the present technology and upcoming that are currently using in the world. Therefore, it is very important that the universities and IT industries should introduce this course and conduct workshops on topic of cyber physical systems. Cyber physical systems are rising in importance for the modern world. In today's environment, connected systems are becoming more and more important. Cyber physical systems are used today to achieve unique levels of functionality and process optimizations across a wide range of industrial applications. Cyber physical systems are transforming the way humans interact with engineered systems. They are intended to improve the quality of life by performing a sound basis of emerging smart device services. These systems have the potential to provide far reaching benefits in addressing some of the toughest problems that we face as a society. For example, minimize healthcare cost, reducing traffic congestions. About the term cyber-physical systems. The term cyber-physical systems emerged around 2006 when it was coined by Dr. Helen Gill at National Science Foundation in the United States. Cyber-physical systems combine and build on elements from different scientific theories and engineering disciplines, including cybernetics, embedded system, distributed control, sensor network, control theory, and systems engineering. Now I come to explain the definition of cyber physical systems. When we talk about cyber, it is more than software, networking, and embedded computing. So cyber implies to the integration of computation, communications, and controlling. Whereas the physical means here the natural and human-made systems governed by the laws of physics and operating in continuous time. So different definitions exist. Our team at Paluno defined the CPS that cyber-physical systems are interconnected systems that perceive and control real objects and processes. They automatically adapt to the current environment and its constraints. Furthermore, cyber-physical system may consist of heterogeneous components unknown at development time, thus allowing dynamic extension at runtime. The second definitions of cyber physical systems are IT systems or conventional systems that interacting with the physical world to provide services, unlike traditional systems which usually operate restricted to the software or application layer. In this slide, I define some other terms in the same context with cyber physical system, like the Internet of Things, embedded systems, and wireless sensor networks. IoT are systems that provide a service over the traditional internet by enabling human to think or think to things communications. And it is different from CPS. IoT is more related to smart physical devices that use for different efficiency purposes for personal use. However, we can say that IoT is a subset of cyber physical systems. Embedded systems are used to control physical processes. They are standalone devices that usually do not interact with each other. Within the embedded system, the components such as control unit, sensor, and actuators are connected through field buses. On the other hand, wireless sensor network describe a network of wireless sensor interacting with each other. The sensor have limited resources such as low processing memory and power. They interact with the physical world and inform the practitioner about the sense measurement. Cyber physical systems usually have three main layers: the physical layer, network layer, and application layer. The physical layer or data collection layer implies the physical environment and the physical devices like sensors, actuators that are directly interact with it. The physical world is the real world where the CPS is supplied to. Sensors measure the dynamic of the physical world, for example, water level, temperature, and pressure. And actuators are proceeding the commands received from the control unit. They might change the physical world with operational commands like shrinking the water or controlling the pollutions. The measurements from the physical layer and commands to the actuators represent the physical environment. The network layer or data management layer serves as the bridge between the physical and the application layer, and it is essential for the CPS operation. It also networks the sensors and actuators. It is the communications channel for the exchange data measurements from the sensor and command to the actuators. Application layer, which is also sometimes referred as control layer or cyber layer. The control layer is usually placed in this layer, which makes decision based on the received major data collected by the sensor. The controller has the intelligence to decide actions based on the samplings from sensors. Now I come to explain the characteristics of cyber physical systems. Following are the main characteristics. First is distributed control or distributed management. All the nodes in a cyber physical systems are geographically not in the same place. The hardware is sometimes locally distributed from the main computer processing the node's information. The decisions are done in a distributed manner. Heterogeneity, which multiply types of end users and processor who own specific demands for information access and interface control should be supported. In such a complex environment, information sharing and controlling will be a great challenge. Scalability, the set of sensors and actuators should be extended. Real-time operations, in fact, cyber physical systems are the combination of real-time embedded system, distributed control system, and multiple types of communication devices. Hence, CPS inherits all the properties present in their antecedents, which mainly include distributed control and operate in a real-time operation. Autonomy means that data system can be deployed in autonomous without human resources, as every decision and action will be made by the system itself. Each component knows with whom to interact and its own task. Adaptability realized through feedback loops is a key requirement to deal with uncertain operating conditions in CPS. The application areas of CPS: smart grids is an automated electricity network which monitors and controls all its physical environments of electricity infrastructure, being able to supply energy in an efficient and reliable way. The next is smart manufacturing or Industry 4.0. It's related to artificial intelligence and the combination of technology and knowledge to enable optimization and efficiency. CPS use in Industry 4.0 and therefore gains more and more importance. The next is smart transportation. These technology aim to provide innovative services relating to different modes of transport and traffic management and enable users to better inform and make safer and smarter use of transport networks. Smart healthcare can be used for better diagnosis of the disease, improved treatment of the patients, enhanced quality of lives, and then actively message and response to medical ecosystem that needs in an intelligent manner. Smart city city technology allows city officials to interact directly with both community and city infrastructure and to monitor what is happening in the city and how the city is evolving. The last one is smart building. Smart building automation is the automatic centralized control of a building's heating, ventilation, and air conditioning, lighting, and other systems through a building management system or building automation systems. Thanks for the listening. And if any question, you can ask me on my following emails. I will deliver my next lecture on the topic of cybersecurity, which I will explain how to build a secure system. Thank you.